Alright, Hail brothers, welcome back. My name is Levranka and today I'm gonna be continuing where we left off, sort of, okay? So, last time we had our little file hello.p, alright? And it was basically a hello world program written in peso. Now, I went ahead and I'm just going to open it here. Oh, wait. First I need to get into my folder, of course. And let's open up hello.p. Alright, good. So here I have it. And I've added a new instruction here to our language. And and a bunch of instructions actually. This one is a little bit misleading, the name that it has, because it's buff. And what it's actually doing is changing the stream or file that we are working with. So first and foremost, I want to change the name of this to stream, probably, or maybe Phil. Phil is also cute. I'm not entirely sure which name I'm gonna give it. For now, I'm gonna leave it at buff. But we also have this new instruction here, this kin instruction. It's for keyvote in, so actually it should be kv in, right? But for now it's kin. And what it does, it takes input from the keyboard, right? So we want to read from standard in. So actually to use this, I should have to switch stream to 0, which would be standard in. Now the problem with that is that it doesn't actually work like that, because I've just implemented it. And what I'm going to do is take you onto a little tour of the insides of Mammoth, alright? So we're going to go, if I bring up the console here, let's go into Mammoth, and we want the file mains.c, alright, and here we are. And as you can see, it's for the most part tables of instructions, and these are what I call switches, right? So they just tell you which index into the instruction table represents this instruction, and for now it's that the index itself and the argument count. Okay, I had a little trouble with that one. And the instruction table, if I fast forward here, fast upwards here, you can see it is a table of nihil, which it's simply a type def for, if I remember correctly, that would be void, nihil void. So it's a function pointer returning nothing and taking no arguments. That's basically that. And why make it nihils? Why don't I take arguments? Because I am insane, clinically insane. So as you can see, the table is just a long list of function pointers, and once you activate a switch, you say, okay, so this instruction is here, that is written to a long stack, and then the calls are made. You know, it's a little bit interesting. But what I want to look at specifically right now is the kin function, alright? So, let's, if I minimize this here, and I've already spoiled it. So, the first thing you should notice is that some of this code I took from the C programming board, so thanks for that. I don't remember what was his name. It's me 86 or something silly like that. But anyhow, he spelled out, or she, I don't care, spelled out how to do a keyboard hit, which is a Windows console I/O from the header console I/O. That's Konya.h, right? A function from that specific to Windows, which is keyboard hit, and basically what that does is it tells you if there are characters waiting in a STDIN. Now this is useful because when you do something like getcha, right? Getcha, or I think in the console I/O is sketch, I believe. Well, the thing is that call is blocking, right? So it will stop execution of your program until you press enter, or until you press a key. What you want to do a lot of the time is just take whatever is in STDIN, write it somewhere, and that's that. You don't want to block anything, especially when you're doing a like a real-time thing, right? So you have, suppose you have a loop which, I don't know, goes forever until you know, well, not is closed or something like that, right? So this is a console application, suppose, and you know, you have your draw calls and your I don't know, your whatever calls, and somewhere you have a check keys, right? Check keys. And what is a check keys? You how do you say? You poll which keys were pressed by the user, and we are in C, and anyhow in any other language I should know better than to put the semicolon there, but you need a check keys, right? And this is always problematic because if you're doing POSIX, Unix, you need to do it one way, and if you're doing Windows, you need to do it another way, and I hate that. I am on Windows personally, but I run on STDIN. Okay, so STDIN is basically like some kind of emulation. Okay, so it gives you some POSIX things like Unistandard here, right? And so you get sleep and you get all of these lovely functions, but they are Windows re-implementations of those functions. So you're still doing Windows under the hood. Now, why not just use console I/O since I'm on Windows? Because I do not care for Windows, one, and two, when I eventually switch to a Libre operating system, I do not want to have to rewrite absolutely everything. So if I'm still utilizing the names, at least the names of POSIX calls, or at least C standard calls, and whenever I'm having to do non-standard stuff, you know, it's still things that I can get in at least most Linux distributions, you know, GNU/Linux distributions, then I'm all set, right? And it's the porting work is minimal. So that's why I wanted a quote-unquote Linux version of the keyboard hit thing, which does all sorts of fucked up things, because it needs to, you know, it needs to set the terminal to raw mode, right? So that means, well, it's not entirely raw mode, it just desactivates canonical and echoing, which if I'm not mistaken is how do you say that it will not wait until a new line to spit out the thing, right? So it will not keep on buffering. So you press the key, you get the key. No need to wait for a new line. And echo is just putting the thing on the screen. So you disable that, And so now you just say write something, and the user presses a key, you get that key on the buffer, and then you can get char it, and I'm just going to skip over this part, right? Because this is the part I copied and pasted because I didn't know how to do this, and so I copied and pasted. And from what I can tell, what this file control, if I'm not mistaken here, does is it takes the numerical identificator of a particular file or stream, and I suppose this one is getting you some kind of descriptor or something, and it's returning it into here, and then we're utilizing that descriptor and setting a particular flag, which is this, be non-blocking, which I'm not entirely sure how those behaviors work together. If someone can reference me to a manual, that will be very nice, but I have not found extensive information on how the fuck does any of this work, and so I have limited myself to just second guessing and copy and pasting. Alright, and so we get char. We can get char without blocking the application. Now we need to know what the fuck that was, and more importantly, I want to know how many characters are waiting on STDIN. Alright, that's good thus far? Okay, so a little bit of this is, well, it's a little bit of a mindfuck. I'll let you figure it out for yourselves. It's not really a mindfuck, but I don't want to talk about it. Alright? But the line is, it gives me the number of characters waiting on the buffer, and it copies those characters over to another buffer which I can use. Not on the buffer, on the stream. Alright. So how many characters are waiting on STDIN? We consume those characters, we copy them over to a buffer that I have actual control over. So that's how the basis of how that works. And is that a problem? Yes, it is a problem, because if you remember, and I'm going to switch over to hello, like I said, we have this buff thing which simply says which stream or file are we operating on. The idea here is that if I want to write to STDIN like a fool, I should be able to do that. That's the principle. It is, it doesn't matter if it is stupid. If I want to, then I should be able to do it. Whether it's a bad idea or not, that's the programmer's responsibility. But the way Kin is coded, because of sort of all of this crap that I've been trying to explain, the way I had to write that, I sort of had to hard code STDIN as the only stream that Kin will work with. And that, to me, is a bunch of shit. So, I'm going to do two things. First and foremost, I'm going to show you what this does, what this program does, alright? So, we are going to see that now. And I'm going to change to the console here. And so, okay, let's run this program. And there's a sleep there in the middle, so I can actually type something, right, and see if it's there. So there's that. So it's going to be a little bit weird, but hopefully you will not mind. And we're going to do hello.p and no memory layout. Okay, so it says type, I type, and it gives me how many characters I typed and what I typed, more importantly. I mean, they're equally important, right? But when I'm doing this in a certain way, I am creating a string, and like I said, we do not null terminate. We always need to know how long the string is, right? Whenever we're doing operations with strings, we need to know. And so, let's try typing a little bit more. Alright, and as you can see, I typed a bunch of garbage and it tells me how long my garbage is. So this thing works, but it only works at reading standard in, right? What if we want to read from some other buffer, right? We should be able to do that. We have this corner case where standard in is a bunch of mal-designed fuck, and it's very hard to work with in the way that you want to work with, and there's all of this tinkering you have to do and googling around for solutions and copy and pasting. But we might also want to read from a regular file, right? And we might want to know how many characters are in that file. So I'm going to try and sort of code that out, you know, like not off camera, right? I'm going to try and do it on video, right? I'm going to go on record coding this fucking thing. So okay, kin works. Now we want a couple things here. First, what I mentioned about buff. For now, I am leaving buff as it is. But if you think maybe I should change the name, you know, propose, make that proposal, right? Propose a better name. I'm not entirely sure if I like buff. I just can't think of something better, and I do not like to use stream, right? I know the stream and buffer are two different things, so that's why, you know, it clashes with my conscience. But I do not think that stream or file is the... Well, maybe file will be the right one, no? Could be. Well, for now it is buff. For now it is buff. So what I'm going to do is I'm going to work on kin. I'm going to work on kin and make it read from any file while still keeping the standard in corner case. That alright? Okay? Good. So let's try this. I'm going to make it so, because right now this takes no arguments. I'm going to make it so it takes a single argument, which is where to write the red bytes into. Okay? And so we need a reg. And I'm going to say reg vars again. And I'm just going to have, let me make, I think 3 would be okay. So let's have, how much would that be? I think 64 bytes. Yeah, 64 bytes a string, that's good enough. Let's do char3 and we're going to call it rd for read. Okay. So we're going to take whatever is in standard out and read that. Good. Okay. And then we're going to reap, because reaping actually flushes the buffer, obviously. It flushes everything. So oh, and actually we have I forgot about this. We have ret now, so we can make functions, right? So you the way it works is simple. You call, it goes to whatever you say it had to go. It goes tuk 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 tuk, and when it encounters ret, it goes to the next line from when you called it. That's basically how it works. And if you have an intermediate call here, call whatever, it will go into whatever, right? It will go into proc whatever, and it will do da 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 until it comes into ret, and then it will come to the next line and keep executing, and so on and so forth. It's a stack. It's a stack, so hopefully it never misses. You do have a call depth of 256. It can be made bigger, but you know, I don't usually exceed that, so it's not a problem for me. And therefore not a problem for the language. So yeah, there's that. Okay, so let's read into kin. Let's read into rd actually. So let's go here And the first thing I have to do, and I think I've already done this. No, I need to change the arc count on kin. Easy enough. Let's just do that. Done. Good. So now let's first off let's remove the blocking, the manual, quote unquote blocking I was doing here, just to test that this thing was working correctly. Now I don't need it, and instead of using get char, I think I need to use what's the name of the goddamn function? Is it get c? The one that lets me specify a file. Was it that one? I'm gonna have to check because I don't fucking remember. So let's do man, and I think it's get c. No? All right. So this is my life, by the way. This is my life. Man pages. So getC is a macro defined in the standard. You can use getC to get the next single character from the file or stream identified by FP. As desired effect, getC advances the file current position indicator. That's okay. For a subroutine version of this macro C, F getC. Alright, F getC, but would that be a blocker? Well, probably not, because we're already doing all of this stuff here. So probably we can take the file now, file number, I think it is, of a given file, right? A given file pointer, and just pass that to this, and that will ensure that our fgetC is non-blocking. But I'm not entirely sure, so let's go back into the manual and look at fgetC. And yeah, I have no fucking idea about IO functions. What can I say? No, I'm used to doing this kind of thing in DOS, where you do keyboard hit and getch, and that's that most of the time. I'm used to that kind of thing. But this whole fuckery, that's new to me. So let's see. Use fgetC to get the next single character from the file or stream identified by FP. Alright, so up until this sounds like the same thing. As a side effect, advances. Is it the same thing or what? fgetC unlocked is a non-thread safe version of getC. fgetC unlocked might only safely be used within a scope protected by a locked file, or I'm not going to try and pronounce that. Try locked file and a fun locked file. Fun. F unlocked file. This function may safely be used in a multi-thread program while the invoking thread owns the file object. So then again, it's unsuccessful call to the block file. Alright, what is the point of this? Right, so what is the difference? It's not a macro, it's a process. That's basically the difference. So is the implementation the same? I mean, I feel like those kinds of things. This is a problem. Why do I get all of this explanation, but I don't get the real difference between macro and function version? Is the implementation the same? Do I have to dig through the source file not to know that? You know what? Fuck all of this. I'm just going to use the macro version because I'm only using it in one function, so it's, it doesn't make that big of a difference. If I was going to use it everywhere, then I would consider the procedure version. But I've used getC before, I know that it works, or at least I think it does, and so I'm going to go with that. Now, how do we point to the file being pointed at by, or like I've been talking about, the buff? What is buff pointing to? Right? Buff is changing what we're pointing to. We want to take that file descriptor, file/stream, whatever. We want to take that descriptor and work that into kin. How do we do that? I'm going to show you. we have here in boxes, this is boxes, map boxes.h, and here we have this thing, the mam string, the mammoth stream, not string, stream, which, you know, it uses this sort of IVM mainframe kind of tagline, RAM disk, it's all storage, baby, right? That kind of bullshit. And what does it have? Position within that stream, total size or capacity, upper bound of that chunk of whatever memory, on-chip memory, on-disk memory, doesn't matter. The utilized capacity, and this I'm just going to draw it because it doesn't actually make sense the way I've implemented it, but you're just gonna have to roll with it. So let's draw a unit, and yeah, that's good enough. Okay, so suppose this would actually be 1, 2, 3. This would actually be let's do it for real. Let's do it for real. Okay, so it would be 0 and there. Okay, so this is 4 memory units, right? So that's 8 bytes per one of these. So each one of these is 8 bytes. Okay. Suppose that we start at here. This is 0 and this is F, right? And here would be 0, 0, and here would be 0F. And so here we have 1, 0, and here we have 1F, right? And it goes on. It goes on. Let me just do one more line so that it's absolutely clear what the pattern here is, right? So this is one reason why I think I've explained this. This is one reason why every last pointer is 16 aligned, because I'm a lousy mathematician, and so I like it when operations I need to do frequently are as easy as possible. So suppose that our stream starts here, right? And we write some bytes to it, right? Now, what would the size of this file would be? The total size would be the distance from here, let me just go there, from here to 0, 0 to 2F, so it would be 2F plus 1, so 30, which would be 48 bytes, no? Yeah, I think so, 48. You're going to do, yeah, 48. So we would have that many bytes total. We cannot exceed that. If we exceed that, we have a problem. So that's why we need to know our upper bound. Current position would be where we're going to draw next, right? So we started here, that would be, position would be 0, we drew that, we inserted that byte into our stream, and now we're at position 1, right? So cur is now 1. How much is used? Used would be also 1, because we've only used 1 byte a mem, right? But suppose we utilize something like the fseek. No? We do an fseek, and we want to move the cursor ahead and write not at the position 1, maybe we want to rewrite the position we've just written, and just to be a little bit better with this, I'm going to write a few more characters there. And suppose that we are here at 4 and we realize, I don't know, we've made a mistake or something, doesn't matter, we want to go back. No? And so we fseek back to the beginning, and we go here. Cur is now 0. Use is still 3. Yeah. So suppose that now we write a number of bytes, a bigger number of bytes. Suppose we write this entire block and we fill it with money. Now the amount of used bytes would be different than if we just rewrote this thing. And why would I care about something like that? Because I want to know whether oh, I'm sorry, I'm having trouble explaining this. I realize that. I do realize that. The thing is, I want to know how many bytes I have to read whenever I'm trying to read the stream, if I have to interpret it in any way. Because just reading until I encounter null or some other terminator, not good enough. I'm going to follow through with follow through would be the I'm going to insist with the rule that if you have a string, and by definition in peso, a string would be a sequence of memory units of undefined length. Undefined, quote unquote, variable length, because we know that length. Anytime there is a string, we know the length of the string. What is a string? Well, a string would be a little bit more difficult because that size might change, and it might change very frequently. But I still want to know how much there is, because if I find myself again in the situation where there is all of this STDIN fuckery, then I want to know how many bytes are waiting. Well, that's what used is, how many bytes are ready to be consumed. Okay? So good. That's the explanation. I know I'm terrible at explaining these things. My broken English don't help, but you have to roll with that. Okay, all right. So FLG, no, just use it flags for now. The only thing it checks is it a stream, and later I will add, is it a heap, like is it like a heap allocation, or is it an actual file? And by stream, right now, the only thing I mean is it's a standard in, standard out, or standard error. Right? That's basically that. And pointer would be the start of a block of memory, of heap memory, or the start of some stack allocation, right? Or by default the file descriptor, right? So the file pointer. And yes, I realize people fear void pointers, but they're just numbers, right? It's an address, it's a number, and you read as you want. And if you read it as something you should not, it crashes. That's what happens. No, but we have the flag to tell us how to interpret that pointer, and so we can do that. All right. So we have that stream struct, and here in this is mami. All right, the mam interpreter mami, right? And so we have Mami, and Mami has a bunch of things. It has the stack or labels. It has the L values and the M values, which are just sort of like macros. And it has the call stack and lots of things. And it also has a list of streams, right? An array of streams. And we can access that. And we know the current one is the one signaled by stream underscore I. And now we get to it. This is what buff modifies. Okay, it's simple, and I'm going to show you how simple it is. It's a one-liner. It's an instruction, a whole instruction for this one-liner. Yes, absolutely. So boring. And to be fair, it's not really a one-liner because this is a macro, and macros, as we know, are copy and paste operation, and this is what that looks like. All right, so not really a one-liner, but effectively, yes. In practice, yes, it's a one-liner. So okay. on initialization, and I'm just going to show these things to show these things, right? If someone has more questions, they can ask more questions. If YouTube is not blocking comments, because it has been blocking comments, I don't know why. We have here our Mummy, and we have stream, which is our array of streams, and we are initializing. And we do this thing where, you know, it's just like very, very common as far as I know. This is a very common practice that standard in is index 0, standard out index 1, and standard error R index 2. Now, this very, very common thing to see, at least I've seen it a lot, and so I just said, you know, why give a shit about anything? Let's just do it that way. And everybody should understand, right? Everybody should understand. I'm not going to have like a symbolic way to describe it. It's just going to be 0, 1, 2. Simple. Okay. So we can then do this. We can do Mummy stream and look at if I can show you one here. See, we have stream pointer stream, and that's Mummy stream plus Mummy stream underscore I, and we can take that. We can take that, and we have a file descriptor. So let's take that into here. Oh, sorry. And what I'm going to do with this is I'm going to rename it to LM, though that will be low mam. It's a play on low level. Mam, and it's going to be read B. Okay. So read B. We're gonna utilize read B and get our file descriptor. Good. So far, so good. Utilize our file descriptor, and if I can gather my thoughts here for a minute. I want to cast it to a file, right? And I want to get the file now, right? So what I need to do is to file pointer f, and that should be just a straight up cast. And matter of fact, I don't need the intermediate stream probably, but unless I want to do like, well, I'll leave it there. Just if I need to access the cur and things like that, because now I'm not going to try and check if there's already data within it, but at one point I guess I would like to do that, so I'm just going to leave the stream there. And I have this file, and now I can do, what does file now return? Let's check. So man f file now, and please tell me there's an entry. Yes, there is. Okay. Can use file now to return the file descriptor identified by fp. That's all I need to. Oh no, wait. I need to know what the return type is. It's an int. Okay, good. Good. Okay, so we want an int, and it's going to be int f now, and it's just going to be file now of f. Okay, good. So that out of the way, it's actually stream pointer. Okay. And actually, I should check that stream has this flag here set, and you know what? I'm going to say read f. I'm just going to say read stream, and let me check boxes here for a minute, and the check is my stream file. So we want to know if stream flg and matstream file. Right, so this is what we would set to know that this thing is a file, that the operation we're about to do is valid for this string. And so I'm going to say bang. I'm going to say bang. And yeah, I realize that I mix file and stream and buffer, because essentially in my mind they are not that different. This is an exercise on abstraction. Okay, this is an exercise on abstraction. If you can think of multiple things as being the same, then Daddy Bjorn will give you a hug, because you understand abstraction like an idiot. And so, if we are not dealing with a file, we just fail, and we don't explain why. And so let's make a to-do explain why. Do a little bit of error check. Yeah. Okay, error check. And so, good enough. We have that, quote unquote, handled. That corner case is handled, quote unquote. And so, let's try replacing the instances of STDIN file number with just f no. Alright, so let's do that first. So no, and I realize that this might not be portable, and I realize all of this after having gone on a little tangent about portability. But you know what? If I have to change this in the future, this is one function, and I am mocking this function as a problematic one in my mind. I will probably forget, but not really, because these kinds of fucked up operations that make me have to copy paste from a CVOD thing that makes me have to copy from a forum and stuff, right? Like copy paste from the internets, like web developers do. This kind of thing I never do. I never do. I don't even autocomplete. I never do these things. So I remember. It fucks me so much, I remember. So, okay. We want... oh, it's not using STDIN anywhere. It's just the file now. Okay, good. Alright, so just the identificates are good enough. Alright, so... And I'm having trouble speaking because I'm having trouble speaking because I'm not focusing enough on speech. That is my problem. When I don't focus in speech, I talk more, I simplify, I optimize the speech. Alright? I optimize the speech and omit words, because that compiles faster. It compiles much faster. So this should be probably okay. I think there is a possibility for this to not work, but it should probably work. So let's try. But first, before we try, we need to do the fetch. What is the fetch? You look at all of these instructions, all of these instruction functions, all of these implementations of the instructions, and you realize there is this block: 2 fet up, 1 fet up, and the most awesome ones, my favorite ones, have the many fet up. This is variadic arguments. Or when you want to fetch one argument, do something with that, and then do something with the next one. You know, maybe you know how many arguments you have, but you want to fetch them first, no, fetch one first, do a certain thing, then fetch the next one, and so on and so forth. And the way it works is basically one fet just it gives you other, it gives you other, gives you value, and other is just the address of the variable. If it was a variable, the address you fetched from, if there was one, or value would be usually the reference, the value you try to fetch the reference, right? Sometimes you do not have the reference, and so value will be address, and address will be something you should not dereference. It's funky and weird like that. And so we need to do a fet in order to get the values of the arguments. That's the thing. And so we need a one fet operation for kin. Now, kin, what does kin do? Kin, or what is it supposed to do? It is supposed to take an address and write whatever is in our stream, write it to our address, right? Just write it all. And so we want to do a fet for an address, and there is a special code for that. We have this flag here in the fet, in the fetch, and the way it works is if you give it like this, if you turn on the second bit, it gives you it forces it to be a pointer, but not just any pointer, a how do you say, a pointer you can jump to. So it's a corner case. 0 is, think of it as a constant, right? Fetch me a constant, fetch me this value as a constant, and this is what you see here, right? So anytime you see fet and a 0, it's fetch me like it was a constant. And if I can find an example of this, and yeah, I have a whole bunch. You turn in the first bit when you want to do the reference, right? When you're expecting it to be an address, and you also want to dereference it and know the value at that address. All right. I said all right instead of all right. Sometimes, you know, it's sometimes I have an accent and sometimes I don't. It's what happens. It's what happens. Okay, so we want to fetch an address. We want to fetch an address. Do we want the offset and thing? Because when you fetch as the reference, you also get like was it offset from a base pointer, right? Because every base pointer is divisible by 16, is a multiple of 16. But you can access, for instance, you know, we had RD, and RD is divisible by 16, the address of RD, right? But we can add to RD, we can add 3, and we would read from RD plus 3. That would not be an address divisible by 16. When we utilize this, we get this offset as a separate value into offsets. I think it is sub 0, yeah. And sub 1, we would get the offset in memory units, right? And so we have to combine the offset in memory units, that would be blocks of 8 bytes, and the offset in bytes in in this box here, right? So offsets 0, offsets in bytes from 0 to 7, right? And if we have something bigger than that, we increment this, and we have to combine both of those to get our final pointer. Now, if we call it like this, we get those offsets as separate values. And if we call it like this, we do not get the offsets, but we still get the final pointer. We get the operation. It is done anyway because it is treated as a constant. But then, how do we calculate the base pointer? We have a function for that. We have a way to do that. And the way to do that, and I'm going to open So again, and So is one of my favorites because it is so fucking complicated. I thought, you know, writing to a file, yes, I can do that, easy. Not so much. Not so much. But, you know, I had to write this function, which is address other to lock, no? And you give this an address, and it returns you location within our jump table, no? And we have two jump tables within Mami, and I'm going to show you. We have these two jump tables, and we have the standard jump table, which is just uint pointer. Uint pointer just offsets into L values, which is yarvarsar. Yarvarsar. It's just a big box of memory. It's yeah, it's that. It's where you put things, basically. And here we have jump table underscore h. And what is this? It's a list of descriptors. So the value at index 0 of jump table, when we look at index 0 of its parallel brother, we get a descriptor for the file at the same index on here. So you get that. So if we go Mami jumped table f index x, then we take Mami jump table underscore h at index x. This is going to be the ID of this thing right here, of this value right here. And what do we have in ID? We have this thing which I in a very poor naming decision, excuse me, I called label. It's yeah, let's say it is a label, but not really. I changed namings around because I am clinically insane, and so but you know, a label to me, it's this block here, the ID. That's what to me is actually the label, and you can see it's present everywhere. Well, not everywhere, but in a lot of places. And the ID is simple. It's 4 bytes which describe the block. So for instance, it's ins for an instruction. You have type when it's a type. Not very difficult to tell. Is a dirty television when it's a directive. And directives are something like entry. It's just something you're telling the interpreter. It's not necessarily something for the program, although actually it is, but it doesn't matter. And then we have 20 bytes of name, and just name, right? And that's how you hash into it. And how do hash tables work? Well, I'm not gonna go into that, but ID is what you use to hash things in my system. Is what you use. And then you have the location, which is the location of this thing within the table, and then the location of a parent. And the parent, I don't remember what it was, but it's somewhere out there. Doesn't matter. But it also has meta. Meta, not like the Facebook. Meta like metadata, right? Like data about data. And type data I have defined some here, right? So it gives you, things like how big is this block? How many memory units does it need? What's the type ID it was declared as? It has flags too, because we like flags. And we can use that. So we need to use the other to lock thing, because this, what it does is it takes an address and it converts it into a location into the jump table. Now, and once we add the location to our jump table, we can just get things by saying, you know, jump table at index location. Simple enough. So let's copy this. And like I said, I never copy and paste. That is not entirely true. But still, we have to do this thing. And so there is one thing we have to do. We have to check that this is not fatal, right? So fatal is, I think it's -1. I think it's -1 or -2. Doesn't matter. Other to lock is going to return fatal if it cannot find, and if we cannot find that address, we just going to call out, and call out is it's a special kind of printf which I wrote because, you know, like I've said, I am a little bit off in the head, and so we go call out E, and E is for error, and we have M for memory, I think it was, and K for stuff like it is stuff you're supposed to see. E is debug, right? Like debug channel or error channel, doesn't matter. And so let's just print that other not valid. Done. Okay, and let's do the prix pointer, and let's actually put it here. So other not valid. Good. Ah, yeah, that's okay. And so we want to pass in other, and yeah, that should be good enough, right? So after that, we just return ungracefully, and what happens next doesn't matter. Undefined behavior. If you don't know how to handle it, undefined behavior. Simple. That, you know, it's like I should have a show called Terrible Programming Advice. I would be so good at that. Anyhow, we have our location, and so we can do mummy jump table h plus lock to get the label with the meta. Like I said, it's not meta like Facebook is meta like metadata. Okay, and so why did I want it in meta? Now I don't remember. Why did I want it in metadata? What was it that I wanted to check? Oh yeah, I wanted to know the length, right? Because I have to copy what I get from the read. I have to copy what I get from the read, and in order to do that, I need to check how big the block is, and I can do that if I, excuse me, I'm just having a little drink here. That tastes like freedom. Anyhow, that tastes like actually I shouldn't have said that, because now I realize that's like a not American thing to say, and I'm way down souther than Mexico and southern than most things. So anyhow, we have our label. We want to know the size of the thing, right? And so, and now I say alright, okay, good. And that would be string size, if I remember. Yeah, but string size is not encoded as a plain number. I think. if I'm not mistaken, I have to convert this, and I don't remember what the function was. I remember which function it was, but I do not remember what it did. So I'm going to have to look it up. So Grim Mammoth, and that would be maboiler.c. Okay. Let's switch to the editor, and here we go. I'm having to juggle windows around because I have just one monitor. So yeah, get unit cont. These function names are absolutely impossible to pronounce, but bear with me. So get unit count. This would take size, and this is actually not magnitude. Someone has informed me this is not actually magnitude, it's an exponent, but I've already put it magnitude everywhere, so I'm just going to leave it at that. No one is going to notice. No one is going to notice or care. So alright, we have this thing. So alright, so what this does is it takes a size in bytes, and anytime the size is greater than unit size, which is 8, but it could be bigger, but for now I assume it is always 8. If I will not change it, I doubt it. Let's assume it is 8, and it subtracts from size and increases magnitude. I do not think that's actually correct, but I'm not entirely sure. Let me check one function in which I actually use that, and that would be TP adder. Okay, so TP. Oh no, it doesn't use it. It doesn't use it anymore. Doesn't care. Okay, so now I'm stumped for real. Let's go back here and look for the function. So get unit. Okay. Yeah, so I just sent it to 1, and so it means nothing. That's okay. With the string size, right? So yeah. So once again reading once again reading from stuff I copied and pasted. Okay. So like I said, copy and paste. Me copy and paste? No. I would never do that. I would never copy and paste. So okay, so get unit count. I kind of didn't mean to say it like that. But yeah, get unit count. It's hard for me to pronounce. I didn't mean to say like the bad word, okay? Don't think of me that way. So we want this would be our upper bound. So I'm just gonna call it bound because that's what it is. But there's no lower bound. Lower bound will be 0, and okay, we can guess that. And alright, so we have our we have the thing. Now string size should be, yeah, it should give us the 64 bytes because we've initialized this thing with a char 3, right? And that will actually update the string size field. It will update that. And if we did it with just char, then it would be just 16 bytes, and it will update the string size accordingly. And if we declared it as a char but gave it a very long string, then it will also update string size, because I don't know, I guess maybe one day that will be useful. So we have that. We cannot miss. We cannot miss with the boundary. We know that the boundary should, at least in most cases, be correct. And so we have to. We can check if the with the thing we read is bigger than the space we have, right? And so we cannot over copy. All right. So we have our, actually we call this length, now that I think about it. And actually let's do this. Let's do all of this in inside a special, because it's so many little how do you say, little variables that never again show up. That, you know what, I think I'm gonna do them in their own private scope, so to call it. And so I'm gonna have to declare this len, which is what I want to use outside of the scope. I'm gonna declare it outside. Okay, so uint len, and uint is just a type def. That's type def. What was it? Uint 32t. Uint. Yeah, that's that. And alright, so we have uint, other look. Okay, we have the error check and label and lang. What else do we need? We need another thing. We need to know. Actually, this should be bound. I'm sorry. I'm gonna call it size. And length, I'm still gonna use it, but in a different way, and I'm going to explain why in the quickest way possible. So length, or len, is going to be the the abstruse kind of value. And what this is kind of like the used thing in the stream, right? Like, how many characters do you actually have to read? So this is usually a value below the total capacity. Hopefully it is a value below the total capacity of the memory block. And we need that because we're not going to give a fuck. We're going to write straight the whole thing, and then we're going to handle the whole offset thing. Actually, you know what? Let's just do the let's just do the offset calculation right here and now. Why not? So, how does the thing work? Well, first and foremost, we need the actual thing, and that would be uint pointer t. Let's say adder b. Yeah, whatever. Let's say adder b, and that's mummy jump table plus our location. We have that address, and so now what we want to do is to have, it would be adder minus adder b, right? So actually let's call it base. All right, that's easier. Adder minus base, and that basically gives you the distance between the pointer we're pointing to, what the user is trying to grab, and the base pointer. And this base will always be equal or less than adder, right? So we can actually do this how do you say, this subtraction. This subtraction we can always do. And so we need another integer that would be position, and this is just an offset in bytes, because you subtract, you have one pointer. Suppose you have a pointer at this thingy here, right? You have one at F0 and you have another at F3. How much is going to be base minus this is going to be 3, and so you get your position within the buffer. The buffer or memory block, it's all just storage. It's all just storage. The question is it temporal or not? Well, in this case, it will usually be temporal. At least as far as I'm capable of planning ahead, yes, it would be. And so, position and this thing, and now I'm going to do one thing I am very much hated for, which is this aligning of the equal signs, and I do not do this because I want to, I do this because it drives me crazy, okay? Alright, so we have all the values we need. What now? And I'm just going to cast this, just in case. It doesn't matter, the value will always be small enough, at least in most cases it should be small enough that the cast doesn't matter, but the compiler likes to complain. So we have our length, we have our position, we have our size, and I want the address of the length value because I want to update it. I want to update the length value with a little computation. And actually, now that I think about it, let's rename size to max chars, because I've already used this name somewhere else and I like to be consistent. Sometimes I like to be consistent. Isn't that fun? So we have all of this. Now I have to do a little operation which I've done before, but I don't actually remember how it works. So I'm going to have to, instead of copying and pasting in order to get, in order to be a better role model for my juniors and all of that, what I'm going to try and do is walk through the mental process again. Something I probably should not do, but fuck it. I am going to do anyway. So, the idea is we have a position and we have a length. If our position exceeds our size or bound or max characters, then we know that's that's bad, and so we can throw. But rather than throw, I just cap, right? And so, how do you say? Oh no, wait. Oh no, yes. So it has to be length plus position cannot be greater, and I'm just going to put this in parentheses. I know that it's not necessary, but it lets me read this better. This cannot be bigger than max chars, right? It cannot, because max chars is as much as we have, length is what we actually have, so max chars is as much as we can have, length is what we can have, what we already have, I'm sorry, I'm sorry, and position is where we're at. And so position cannot exceed max chars, length cannot exceed max chars, and wait a fucking minute, no, I'm doing this backwards. I don't have to do the length, excuse me, not the length of the buffer. I need to do I'm sorry, I'm a little sick. So I need to do the length returned by what used to be keyboard hit and now is lm read stream or something like that. Yes, this would return a number of characters on our stream. So let us get that length, and so that would be, so fork it, let's just rename DST length, so that would be destination, where we're going to write to, and then we want to have our source length, which is the length of wherever we're taking the information from. Alright, so now we can do the operation. If source length, so this is the volume of the data we're going to copy over, plus our position within the buffer we're going to write to, so destination, this sum cannot exceed our capacity. And so if we do exceed the capacity, we need to cut it. Alright? Alright, and so let's just do it. Let's say source length, let's just shorten it. Alright, let's just shorten it so that we don't copy over more than we want to. How was the operation here? So that was it. Yeah, I can just make it marked chairs, why not? But no. I cannot remember how this operation fucking worked. Oh, how was it? I remember that it's an if. Yes, I know that it's an if. And probably there's a branchless way to do it, but I do not care. And yes, I am already in the realm of copy and pasting things I've already written, because why not? Bad practices. Bad practice number 1 is number 0. Forgive me. Number 0 is say you will not copy and paste and immediately copy and paste. That would be the first one. Oops. Okay, so I have it somewhere around here. Alright, so here, because I've done this kind of thing before and I was very lazy to try and make it its own function. I should actually do that, but then we wouldn't have this much fun, do we? So would we? Not do we? That doesn't matter, linguistics. So mx. Alright, that's so fucking simple. Yeah, so it's the maximum. It's capacity minus position. It's simple, right? So why do I keep forgetting things that easy to remember? I don't know. Max charge minus position, but now we have another problem in that position cannot exceed max charge, and hopefully it wouldn't, but maybe we should check. I'm not going to. Why would I? But then if we have a position bigger than max charge, what happens? This underflows and tries to write a, it makes length bigger than it actually is, and it tries to write a whole bunch of things. Yeah, that would not be good now, would it? But I like to leave the danger, so I'm just going to leave a to do, which it's not that difficult to do, but I want to wrap this up. So source length, we have the string we want to copy. That's what this does. It copies the whatever was on the current file at its current position. It copies whatever was there, and it returns the length of that string, and the actual string is copied into these things, so buffs at some index. We do not care which one. Actually, yes, the 0, the first one. So there's two of these. There's 1 and 2, and 1 is RD, that's for reading, and 1 it's WR, and that's for writing. So yeah, it copies into 0. Alright. So that, and I don't know why my pronunciation fluctuates, but it does. So we have the thing, let's copy the thing, and I'm going to do it in the laziest way possible, because why not? And to get started on that, I'm going to say that mem unit, and that's simply a line, source, and that would be adder. Yeah, adder, just a mem unit cast to adder. Okay, so mem unit cast to adder, and having that, yeah, I think that's good enough. Having that, we can just for int, I'm gonna have to use uint x equals 0, x less than source length, and x plus plus, and now what do we want to do? We want to take something from this buffer starting at this position. Let's assume that it starts at 0. It might not, but just for simplicity, let's do it like this right now, and I will make like the complex things that require me to utilize my brain. I will do that off camera, because else I would be here for 5 hours. I am terribly slow. So excuse me, that's sort of like a tick thing. So what was I doing? Oh yes, I was copying. I want to copy into destination, and I have so the ref to destination, and we copy from here, and yeah, that should probably work. Probably, I say probably. So we copy into destination. Okay. Aha, but there's a problem. There's always a problem, isn't it? I can have an offset, a position into the source, which is not, how do you say, which is not divisible by 8, so it cannot be correctly read as mem unit. Oh no. I know, but adder should do, but no, that's not going to work. No, so actually I'm gonna have to do it the stupid way. Oh, and actually source length is measured in bytes, so yeah, I'm gonna have to cast into a char anyway. Well, that is disappointing, but what you gonna do? So uchar, and that's the same story as uint. That's just the type there for would be uint 8t. So no, uchar. Alright. So uchar source, uchar adder, and I'm gonna put this down here when I'm actually going to use it. So adder. And dst adder, so buff. And now we have a problem, because we want to navigate this. So I'm actually gonna have to create another one of these future pointer destination, and that's future this thing. Yeah, okay. I mixed it up. Sorry. This is source and this is destination. This is the source and this is the destination. So okay, and now we just grow them, no? Yeah, let's just do that. Plus, and that should be that. And so, oh my god. So how long have I been recording? That's 1 hour and 24 minutes. That is a lot. It should not take me this long to do these kinds of things, but well, okay. So let's clear the screen and let's just make mem. And let's see where have I failed horribly. Aha! I knew it! So okay, let's see. Alright, so this one shouldn't be right. So this one is giving me a pointer. And actually I want the reference, so yeah, of course. Thank you, compiler. And over here, no member name string size, right? Because I need to access the meta. So that would be meta.struss and meta.struss. And oh, I did not update the length. So this one I think I do remember. If I'm just gonna do it over here and use a separator to help me read. Okay, so if DST length, and actually I have to dereference this. So if DST length dereference plus position, right, plus position is greater than, what would it be? Source len, yeah, source len on its own is greater than source len on its own, then what is in this thing closing? Oh, that's sloppy, not for me, but I actually want it like that. Okay, so if this thing is like that, then I want to enlarge the DST. Okay, so DST length would be, so should I add position? No. No, wait. Let me think about it. No, actually, it's the other way around. Source len plus position less than DST len, yeah. So this is like how to explain this, because suppose you have a string here, right, and you begin, I'm going to do it right to left. If you start here, your position is 0 and you're trying to copy something that's, I don't know, this long, then you know the total length you have to look at is just this. But if you're starting here, right, so this is your position, then you have to look at this entire block, right? So it's just not 0 anymore, you have to add the position in order to know if you're exceeding the length, which suppose it ends here, I don't know, right? And so I don't know if I've written it right, but what I want to do is to change the length of the destination thing whenever I'm writing, whenever what I'm writing is exceeding this thing here, this boundary here. In that case, I want to update that that number. And if it's shorter, not really, unless it includes this sign, this null term sign, which it's not actually a null term in BISO. It's more like PISO. It's more like everything that comes after this just truncate. It's a truncate actually. It's a trunc term. It's a truncating terminator, but you know, null terminator. You can call it like that if you want. That's it, yeah, as long as you understand the difference, it makes no difference. So that's whenever your string has that special sign, then you know you want to truncate, which would mean shorten the size. If that thing is not present, then we do not. And it is just one thing, so I'm absolutely clear on this. This does not translate to a literal null, right? This is not a byte with the value 0. This is 2 bytes with the literal value 0, and so it would be 30 and the other, well, what is it, 5C, I think. I'm too tired to check the ASCII table, so yeah, let's assume that it is, right? So it's both characters, right? It's both bytes. So you can never write this. You can never write this to a text file and read it with this interpreter, but what would you read with this interpreter that wasn't a file, a BISO file, right? You wouldn't do that. So, okay. So if source length, so the total length that we have, no, source length is the I get so confused with this shit, man. So the thing we're trying to copy plus the position is bigger than what we already have. In that case, we update. Okay, done. Source position, source length. I'm sorry. I'm sorry, man. I'm tired. I'm tired. You know, lots of things happening. I get confused. Okay, so just go there. Okay, done. We have our string. We copy. We have the length. The things done. Okay. Right. What else? I think nothing. So let's clear and make mam again, and let's see where have we gone absolutely horrible. Alright, not so many things. Okay. So right. A function returning non-void. Right, that's good. We don't have much of a problem with that. It's just, yeah, right. I'm used to every function being a void, so no return. And so whenever I say just exit and say nothing, it's just return semicolon. Yeah, I'm used to that. Okay, what else? We have get C. Oh, it needs the file. So I would have never noticed. And then wonder why the program doesn't work, you know. Thank God for GCC, right? So, this thing is F. Okay. Done and done. Good. So let's bring out the console. Up. Why isn't it? I go. Make mam again. Alright. Good. Alright, done. So now let us run our program and see how badly it crashes, okay? So I'm going to read it again because I do not remember what I'm supposed to be testing. So we have a hello world. Actually, this will not work. I need to reap. I need to I need to reap first, and then I should read it. No? Or what? Well, you know what? Let's just test it, and we'll see what happens, right? We just see what happens. But actually, if this flushes, it's not actually. It's going to read null. It's going to just get maybe not null. Maybe it's end of file, or is it end of file? Whatever it reads, it's not going to be very useful. Why do I do things and then I can test shit? Okay, so doesn't matter. Let's just see if it doesn't segfault. Okay, so let's go to the console and let's allow that be. All right. Okay, so it's not a segfault. That's good enough. Usually that's good enough. Okay, so it's saying the adder is not valid, which I don't think. Let's check the memlag and see if okay, so that's not right. Huh. That's definitely not right. What's going on here, eh? How is that address not valid? How? Just how is that address not valid? Oh, because if lock equals fatal, if lock is fatal, not if lock is different from fatal. So this is so right. It's a false positive. It's a false positive. Okay. All right. So let's try run f hello.b. Okay. All right, and we get nothing. So it cannot read anything from standard out because as soon as we reap, there is this thing that happens. When we reap, we write to standard out, and whenever we write, we advance the here I'm going to show you is a straight up f write, right? And when you do that, you're advancing the pointer, the cur, right? So what we need to do is rewind, which is probably a bad idea, a very bad idea. I don't think this will work, but I just want to test that the reading a file works. And I'm too lazy to implement opening and closing. Okay, so what I'm going to do eventually is have a file open, file close, right? So we can open a file like you would and read to it and write to it as you would, but because I am running out of time right now and I'm really sleepy, I'm not going to do that. Okay, so let's just try rewinding this. I'm pretty sure it's not going to work, but let's just see what happens. And so rewind F, and that's basically that. And let's try compiling. Alright, and now I run mmf lop, and we still read nothing. Okay, so yeah, not going to work. Well, that's a shame. There's another thing we can do. Let's just forget about this. Let's just forget about this, and I'm going to do is some, I don't know, like there's no easy way to test this whole reading thing without you know. Why do I do things? Okay, so I would need to add back the sleep thing and type, but didn't I show you that at the beginning? I think I did, right? I show you that. So that works. We know we can read from a file. But the thing is, I cannot open a file. I cannot open a different file. I'm only working with standard in, standard out, and those fuckery, lots of fuckery. So they're not files, they're streams. I think the streams. Yeah, there should be streams. Doesn't matter. So what? What do we do? Well, you know what? I think what I'm going to do is just clear here and log off for the day. Alright, so what I'm going to do is I'm just going to implement the file open and file close tomorrow or someday, and then when I have that and I can open and close file normally, I would just write from file normally and showcase that, right? And we leave hello world as hello world, and we will not fuck with it anymore. The good thing is, because we have console input, we could try the whole hello what's your name thing, right? But I do not have string formatting, so I could still make it work, but I'm not going to do it today because I'm tired. And so this is the end of this episode. I hope you liked it, and the next one is going to be a little bit better. Alright, this one is a little bit shit, right? This one was a little bit shitty, but okay, next one's gonna be better, don't worry. And so yeah, thanks for watching. I hope you have a good day, and so goodbye.